Hello! ChatGPT, you've all heard about it. It's the most viral app ever. It's amazing, it's smart, crazy.
But it has a knowledge cutoff and it is not aware of recent events, such as how many users does its mobile app have.
Today we're going to tackle exactly that. We're going to integrate external knowledge source into ChatGPT. Specifically, we're going to embed the news articles from TechCrunch and use a trivial mechanism to make ChatGPT smarter.
And that's how we bypass the knowledge cutoff and give the correct answer.
Join the shot.
Cheers. Right, okay. So, we're gonna ask ChatGPT how many users, how many installs actually does it app have,
Right.
right? Like the mobile app I meant. So, let's ask it. And probably it will not know how many installs does we don't expect it to know the answer because it has a knowledge cutoff, September 21. Yeah, it doesn't know.
Alright, so let's solve it.
And as we said, we're gonna use TechCrunch as our data source that we're gonna integrate. And we'll begin with scraping articles from it. So for example, this one is one of the articles in TechCrunch, and luckily we can just trim the name of the article and then to see articles by date, which is very convenient.
Our first goal is to get a list of articles, so,
Exactly.
and then we scrape them one by one. So here is the list of articles from May 28.
28, exactly. So let's see what's the object that has this link in it. I guess a tag. So here's the a tag with this class. Cool. Let's begin coding. Let's begin with import requests, and you're gonna use Beautiful Soup to parse the HTML. So
Beautiful package.
beautiful package it is. Beautiful. Cool. So that's the that's the URL we're gonna use, and I'm gonna use request to parse it and to get it as a text.
We start with that date, that specific date, and later on we iterate to a range of dates.
Exactly. If we wrap it, if we initiate Beautiful Soup with it, we can then find relevant elements, and in this case we're gonna look for A tags. So let's
A tags are all the links, right?
find all A, right? And we saw that we are interested in specific classes let's look for it again. Sorry.
All right.
Okay. So Beautiful Soup makes our job very easy. And we're actually interested in the href because we want
The href attribute.
href attribute of it. So for A in this list, we're gonna take href. Cool.
Nice.
Sounds good. So let's wrap it into a function that, given a date, it would give us all the URLs. But we need to parse the date into the link here. So let's import datetime.
To make it much more easier to handle all the date manipulations, right?
Yeah, exactly. And we said we are in May 28. We want to add it and cut it into the website, the link, right? Yeah, but we can't really use it as an object, so there's a function strftime, and let's parse it in the right format, so it will fit in. Whoops, almost.
Almost. All right.
All right. So that's what we're gonna use here. but our date will be coming from outside as a parameter. Cool. Now let's create a list of all the URLs by looking on specific dates. So we're talking about May 28, but maybe let's look for, I don't know.
Let's get back 5 days.
5 days, last 5 days, that's cool. So let's do it.
And by the way, it's going to be a small POC database of 5 days, right? But in the real life, we can scrape much more, and we can use external databases, organizational databases, everything.
You can make it much more robust. So the way we're going to do it is I'm going to take the May 28th and we're going to iterate over days backwards to it. So let's import time delta.
I guess it's going to be readable in a couple of seconds.
Yes. Let's import from TechAdem.
I think you have 2 for loops.
Oops. Sorry. Yeah.
Okay.
Our function, we get datetime, May 28th, and we're going to iterate over I in range of the last 5 days. Let's use trange from TechAdem. Let's see what we get. Right.
Quite fast.
Quite fast. Let's see. Right, so we get a list of URLs, but actually it's a list of lists because for each date we have its own list. So let's just concat them by using a simple sum. Begins with an empty list, and here we go.
Cool.
So we have a list of URLs.
Okay, so next phase, we're gonna, for each URL, we want to scrape the article itself,
the content itself.
Yeah, and get it into our database. So
let's do it.
Let's start with a concrete URL. Right. So we have this URL. Again, we're going to use a beautiful soup. Let's wait for it to load.
Exactly.
Right. So here is the article. We can see that there are many paragraph tags under this div, which has the class article content. So let's begin. I just copy this code here, nice piece of code, and I'll change it as we need. So we'll get that URL into beautiful soup, but here what we want to do is actually a bit different. We want to use the div tag.
Yeah.
And we saw it has a, let's see again, what's the class it has? All right, article content. All right. So we have the div, actually it's a list, and we know there's only one.
We need only one, yeah.
And now we could use, okay, we have this paragraph, right, the P. Let's use that, find all P, and it's going to be a list of paragraphs, and for each paragraph let's use the text. All right, so here's the list of paragraphs, and let's wrap it up into a function, get article.
Yeah. So given a URL, we're gonna just return the list of paragraphs of that URL.
All right, so now we can continue. Let's import pandas. It will be useful.
That's the time.
And let's construct a data frame of articles. And it's gonna be, let's have two fields, the URLs and the article. Article, it's gonna be for each URL in URLs. we're gonna use our function get article. And let's understand how much time it's gonna take us with Kedem.
Let's wrap it.
All right. So this time it's a bit slower. It's gonna give us time to explain what's next. How are we gonna integrate it into ChatGPT, right? We essentially want to integrate the relevant pieces of information because we can't just concatenate all the information, right? We have to choose the right pieces of information and we have to choose which granularity we want to use. And we can just find the most relevant article and just pass its entire article. But let's solve it in a bit, or let's solve it now. What did it want? Timeout. Let's run it again and continue with the explanation. So what we'll want to do instead of giving the entire article, which can be, we're gonna pay more per tokens, right? We don't want to do that.
That's also misleading the ChatGPT, by the way.
Yeah, maybe. So let's just pass
too much information.
The most relevant information.
Yeah.
We'll use granularity of paragraphs. Because it's the right granularity we as humans sometimes use, right?
Exactly.
So let's use that. So let's go ahead. We want. Doesn't like us, right? Max retries exceeded.
What's going on?
There's no such article. Maybe TechCrunch is an issue. So let's do is following. We have to filter out, right? So let's try. And if there's nothing, just return nothing, right? So we can, and then we'll have to filter out.
Go on.
Yeah.
Finally.
So, okay, we have here we're gonna have this data frame called articles. Let's just stop this menace of scrolling. All right. So we have these articles. It's gonna be having 2 columns, URL and article, and we know
which is a list of paragraphs.
Or none, right? So if article, let's not an A. Let's filter out those bad articles. And we want to use the granularity of paragraphs, and we know the article column is a list of paragraphs. So let's use we can articles dot explode on that column, and in a second we'll see what we'll get. It's going to be cool. We're going to have a new data frame where each row, instead of containing a list of paragraphs, it will just contain a single paragraph.
Exactly what you need.
So, and we'll also let's rename it so it will be more straightforward.
Because now the column is not article anymore, it's going to be just a paragraph.
Right, and if you're curious how much time we left, wow.
A bit more,
but let's continue. Okay, so we're going to have articles, right? And 2 columns, one for URL and one for the paragraph.
Mm-hmm.
And by the way, we already know TechCrunch and the web as a whole. There are rich paragraphs like this, but sometimes there are,
very maybe short ones.
Maybe this is under paragraph as well. We don't want those too short ones because it's not going to contain the right information, and not none.
No, you need the articles.
Sorry. And so again, just let's see how it looks, right? Here are the articles before the explosion and after the explosion and the renaming for each. You
didn't save it.
We have to save it. Let's call it paragraphs.
Yeah. Right.
Okay, for each URL, there are several paragraphs.
Here's a good example of a very short paragraph we want to filter out, I guess.
Sounds good?
Yeah.
Sounds good.
Sounds good to work.
So let's do this. Paragraphs where the paragraph column, let's count how many words it has, and let's actually count them. And if it contains more than
maybe 10
words, all right,
it's legit. Yeah.
So we're left with 1001 legit paragraphs And how are we gonna find the most relevant paragraph?
It's a good question. For that, we're going to use numerical representation for the paragraph and for the query. And we would like to find the paragraph that is most similar to the query.
Right. And
the numerical representation is actually embeddings. For that, we're going to use OpenAI's embedding endpoint. And we're going to embed all the paragraphs. And then we'll do the same for the query and find the most relevant.
Sounds good.
So let's look for OpenAI embeddings, like all of you can do. Yeah, that's the first link. There's a lot of documentation, not very relevant for us. Let's skip to the chase, and here it is.
Really easy.
Right. All right. So we don't want to save for the sake of our example, we don't want to save all of these. And here is the function. But before we're going to use it, there's a package, OpenAI. We're going to import it. So we're going to import OpenAI, and we're going to also need to set our API key. So
right. Whenever you register to this service, OpenAI or other providers, you get an API key, and using that API key, you can actually access the service. So we just save it in a file. So we want to keep it private.
Exactly. So
right.
You're set. And yeah, cool. We have this function. Let's see. So if we take paragraphs, one of the paragraphs, right?
Let's see how embedding looks like.
How does the embeddings look like? Cool. We have numerical representation. In this example, it's
yeah, to me it looks like garbage, but for the model it makes a lot of sense, all those numbers.
1536, that's the dimension of the embedding.
Cool.
That's cool. So let's just apply to all of the paragraphs as a new column in the data frame. So let's call the new column just embedding. Paragraphs. Oh, sorry. Wow. Embeddings.
Cool.
Embedding. We're gonna apply it on the paragraph column like we just did.
Mm-hmm.
We're gonna actually use a progress apply from TechCrunch, so let's just load it. Progress apply.
Okay. For each row, we'll get the embedding.
The embeddings and save it in a new column.
Cool.
Let's see.
Progress.
Progress.
No.
No, progress.
Right.
Sorry. Okay, so we have a lot of time to wait. Maybe 10 minutes.
Let's make it a bit shorter. What do you say?
Let's try to accelerate the process. So, OpenAI's endpoint for embeddings can also get a batch of texts, and that would help us to streamline the whole thing. So let's just
instead of doing it one by one, we use batches, and it uses GPUs behind the scenes, and it's much more fast.
Much fast, exactly. So let's change our function and make it to customize it to get list of text. So that's going to be texts. And now we just need to make the necessary adaptations. So we're going to do the same replacement as I did for each of the texts, right? Right? But now we still have it as a list. And then in our embeddings, we're going to send the list of texts.
No, the 0 here is because it used to be 1, but now it's a batch.
But now it's a batch, right? So let's see, for res, in this list of res, we're gonna take the embeddings.
So just a minor adaptation. Now, given a list of texts, it will return a list of embedding.
Exactly. Now we're gonna use split it to batches, and each time we're gonna feed in a different batch. So let's take a batch size of
100.
100 sounds good. Right. So let's iterate over from 0 to len of paragraphs with batch size, step size. That's going to be the step size actually. And let's drop this one. And our embeddings list will get the relevant batch. So in that sense, we're going to feed into get embeddings paragraphs from I till I plus batch size. That's going to be super simple. We just need to remember we're going to feed in the paragraph column. Cool.
So let's see how much time it's going to take. Instead of a couple of minutes, it's going to take, let's see,
hopefully a couple of seconds.
really fast.
Very fast.
Cool.
So now we have embeddings. It's a list of all the embeddings. Let's just assign them to the paragraph.
Yeah, new column in the data frame.
Yeah, exactly. Right, so how does it look like? Just to make sure. Cool. URL, paragraph, and it's your embedding.
Cool. So now we have everything set in place to actually use the embeddings, right? So we have our query, right? Let's copy it from the ChatGPT. How many install does ChatGPT have?
App, actually, it used to be
App, actually, yeah. Maybe let's just make sure it's the app and not.
Yeah.
Actually, it makes sense. You don't have to install the website, right? So, okay, it still doesn't know. Right, so let's get here. This is going to be our query. And we're going to, first we have to embed it into the same embedding space so
exactly.
we'll be able to find the match, right? So, query embedding is going to be...
Well, it's the same function as we did before, but now it is just a single query, so we need to wrap it.
Right.
Cool.
So now let's calculate the distance. So let's use NumPy for that. And let's take the embedding column, and for each we'll do the following. Just do the dot product, right, between the embedding and the query embedding.
Exactly.
And it's a good practice maybe to also normalize it by just, dividing it by the norm of each of the vectors of the embeddings.
It's like cosine similarity.
Yeah, so dot norm of the embedding multiplied by the query embedding. Query. All right, so here we're gonna have the distances, and we just let's use the top, the best paragraph. We actually could use several paragraphs. Let's take the argmax.
Yeah, we're gonna take the most relevant paragraph to our question.
That's the best index, right?
Yeah,
and the best paragraph is gonna be the paragraph at that location.
Yes, exactly.
Right, so now it's going to be pretty simple. The easiest way to integrate that knowledge into ChatGPT is going to just by using a smart prompt, right?
Yeah, exactly, in the prompt.
So if the prompt in our naive case was simply the query, right? And we saw it didn't work in this case. Now we're going to integrate the knowledge. So let's make it easier for ChatGPT and do some prompt engineering.
Understand, yeah.
So here's a piece of text and the best paragraph.
Yeah.
And all right. And I have here's a question about the text. Plus query. And actually, maybe it's enough, but ChatGPT has the tendency to just keep talking. So let's keep it short. Do it like so. Please answer in a concise manner. Right. So now the finale.
Let's see how it looks like.
Here's the prompt, and what we're gonna do is just
Maybe a /n before the query gonna be make more sense.
You want here as well?
Here.
All right. Sorry. Let's do it. Right. Now it looks better, right?
Yeah.
So let's get here and let's change the question.
The question. Hopefully now it would know the answer. The ChatGPT app has 500,000 downloads.
So two amazing things, right? The first is that it has 500,000 downloads.
That's crazy.
Yeah. And the second thing is how easy it is to integrate the knowledge, right? So let's just see how easy it was.
Exactly. So let's go back on what we had now. So we began this video, like with this lecture, with constructing our database. Here we use TechCrunch. We get URLs for each of the dates. We get a list of URLs, and then we parse them into articles. The next step would be to explode them to the paragraph levels. Now we have for each URL paragraph the granularity of the database, of the data frame. Sorry. Then we use the Embeddings API from OpenAI to find a numerical representation for each of the paragraphs. Then we just found the most similar, right, paragraph, fed it back to ChatGPT, and voila, ChatGPT managed to give us the right answer.
So we hope you had some great time with us, and see you.
Bye-bye.